Welcome to the CompTIA Project Plus Prepcast by baremetalcyber.com. Project impact awareness begins with the understanding that decisions made within a project can affect not only internal objectives, but also the environment and surrounding communities. These effects can occur whether or not they are part of the project's formal deliverables, and they may influence both the perception and the actual performance of the project in the eyes of stakeholders. A project manager must evaluate how each decision aligns with broader environmental and social considerations, while ensuring that core objectives are met. The concept of ripple effects describes how one choice within a project can cause secondary impacts beyond the immediate scope of work. These can include indirect environmental changes, social shifts, or economic consequences in the local area. Recognizing these ripple effects allows a project manager to anticipate issues that could influence community support, regulatory compliance, or the project's long-term sustainability. Environmental, social, and governance-aligned project management includes proactive impact assessment as part of its planning and execution activities. By integrating these assessments early, the project team can identify potential issues before they develop into risks that threaten cost, schedule, or quality. This approach also demonstrates responsibility to sponsors, regulators, and community stakeholders who expect projects to operate within accepted environmental and social parameters. Key environmental impact areas for projects include the consumption of resources, the generation of waste, and the release of emissions into the air, water, or soil. Projects in industries such as construction, manufacturing, and IT infrastructure can have substantial environmental footprints, and these must be evaluated both for compliance and for alignment with organizational values. The project manager is responsible for determining which impact areas are most relevant and ensuring that these are addressed in project planning and control processes. Each of these impact areas can result in measurable environmental consequences. Resource consumption can deplete critical materials or cause shortages in local markets. Waste generation can create challenges in storage, handling, and disposal, with potential for environmental contamination. Emissions from operations or supporting activities can contribute to air and water quality issues. Understanding the scale and significance of these impacts is essential for planning mitigation measures. Impacts may be classified as direct or indirect, depending on the nature of the project's activities. Direct impacts are those that occur as a result of project actions, such as deforestation caused by site clearance. Indirect impacts are those that occur as a result of related activities, such as increased energy use from equipment or supply chain operations. Differentiating between these types helps the project manager plan targeted responses and measure effectiveness more accurately. Common environmental risks in projects include pollution, habitat disruption, and violations of environmental regulations. Pollution can be chemical, biological, or noise-related, each requiring different mitigation strategies. Habitat disruption can result from altering land use or introducing structures that affect wildlife. Regulatory violations can occur if permits are not secured or compliance measures are ignored, potentially resulting in fines or work stoppages. Failure to mitigate environmental risks can lead to project delays, increased costs, and damaged relationships with stakeholders. In some cases, regulatory agencies may suspend operations until corrective actions are taken, causing significant schedule impacts. This underscores the importance of identifying risks early and integrating mitigation strategies into the project plan. Long-term consequences of unmanaged environmental risks can extend beyond the project's closeout. Damage to ecosystems may take years to reverse, and public trust can be difficult to rebuild once lost. This can influence not only the project in question, but also the organization's ability to secure future work in affected regions or industries. Environmental risk mitigation strategies include selecting cleaner technologies that produce fewer emissions, designing processes to minimize material waste, and planning operations to maximize efficiency. These strategies can be supported by industry standards, sustainability certifications, and advancements in materials science. The project manager should document these measures to provide evidence of compliance and responsible practice. Conducting environmental impact assessments before execution begins allows the project team to systematically evaluate potential risks and plan for their mitigation. These assessments often involve data collection, modeling, and consultation with stakeholders to ensure that potential impacts are fully understood. The findings can be used to adjust project scope, methods, or scheduling to reduce negative effects. Collaboration with environmental consultants can provide access to expertise and tools that the internal project team may not possess. Consultants can assist in identifying relevant regulations, designing monitoring systems, and recommending best practices for minimizing impact. Engaging these experts early in the planning process increases the likelihood of achieving both compliance and environmental performance goals. Project managers may also need to evaluate the carbon footprint associated with their project's operations or supply chain. This assessment considers all sources of carbon dioxide emissions, including those from travel, energy consumption, and material production. Calculating the carbon footprint provides a baseline against which reduction measures can be planned and measured. Sources of emissions often include activities outside the immediate project site, such as transportation of materials, vendor operations, and energy used in manufacturing components. A comprehensive evaluation must account for these indirect sources to produce an accurate emissions profile. Carbon reduction plans may involve switching to renewable energy sources, implementing energy-efficient processes, or purchasing carbon offsets to balance unavoidable emissions. These measures should be documented in the project plan and monitored throughout the project to ensure targets are met. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Waste management and sustainable disposal are critical considerations for reducing the environmental impact of a project. This includes planning for the safe handling and disposal of construction debris, hazardous materials, or obsolete electronic equipment. Effective waste management strategies may involve identifying recycling opportunities, reusing materials where possible, and ensuring that disposal methods comply with local regulations. Proper planning in this area can reduce environmental harm and often result in cost savings for the project. Recycling and reuse initiatives contribute to environmental sustainability and may improve project efficiency. Materials such as metals, plastics, and electronics can often be recovered and processed for reuse rather than sent to landfills. These practices can lower procurement costs, reduce the project's overall waste output, and demonstrate alignment with environmental stewardship goals that may be valued by stakeholders and regulatory bodies. Local regulations may mandate specific procedures for the handling, transportation, and disposal of certain waste types. These can vary significantly between jurisdictions and may require the use of licensed disposal providers or specific documentation to confirm compliance. A project manager must ensure that the project team is aware of and follows these requirements to avoid legal penalties and delays. Sourcing materials responsibly supports both environmental and social objectives. This includes selecting conflict-free minerals, recycled inputs, or certified sustainable products that meet established environmental standards. Responsible sourcing can also involve evaluating supplier practices to ensure they align with the project's environmental and social commitments. Vendors should meet defined sustainability standards and maintain traceability for materials supplied to the project. This may involve requiring certifications, conducting audits, or reviewing supply chain documentation. These measures help confirm that materials are produced in an environmentally responsible and ethical manner. Responsible sourcing reduces reputational risks and strengthens the project's alignment with environmental stewardship objectives. It demonstrates due diligence in material selection, which can enhance stakeholder trust and contribute to compliance with broader environmental, social, and governance targets. Projects also have social impacts that must be understood and managed. These impacts can include creating jobs, affecting worker safety, influencing education or skills development, and changing local infrastructure. Positive social outcomes can improve community support, while negative impacts may generate resistance or conflict. When social impacts are beneficial, they can strengthen a project's social license to operate. This refers to the acceptance and ongoing approval of a project by its stakeholders and community. Delivering tangible benefits to the community, such as infrastructure improvements or access to training programs, can reduce the risk of opposition. Negative social impacts can result in protests, lawsuits, or boycotts that disrupt project progress. These can occur if the community feels excluded from decision-making, experiences displacement, or perceives that the project does not respect local needs or values. Addressing these concerns proactively is essential for maintaining project stability. Inclusive planning helps ensure that projects deliver meaningful social benefits. This involves engaging with local stakeholders early and incorporating their input into project decisions. Such engagement can take the form of public meetings, surveys, or advisory committees. Hiring locally, supporting community infrastructure, or donating technology or resources are practical ways to improve outcomes for affected populations. These actions can create lasting goodwill and provide benefits that extend beyond the project's operational phase. Aligning project activities with community values helps secure the trust and cooperation of stakeholders. This alignment makes it more likely that the project will be completed without disruption, and that the outcomes will be accepted and supported in the long term. Labor practices and human rights considerations are key aspects of the social dimension. A project manager must ensure that all work is performed under ethical conditions, with fair wages, safe working environments, and respect for workers' rights. This applies not only to direct employees, but also to contractors and suppliers. Violations such as the use of forced labor, unsafe facilities, or discriminatory practices can cause severe reputational and legal consequences for a project and its sponsoring organization. Preventing such issues requires clear contractual requirements, ongoing monitoring, and corrective actions when necessary. Many environmental, social, and governance scoring frameworks include labor compliance as a key performance indicator. These scores can influence investor decisions, stakeholder support, and market opportunities, making them an important consideration for project managers. Diversity and equity in project design ensure that infrastructure, services, or products are accessible and relevant to all demographics. This requires attention to accessibility standards, cultural considerations, and equitable distribution of benefits. Addressing equity in planning supports sustainable project value by ensuring that no group is unfairly disadvantaged or excluded from the benefits of the project. It also strengthens compliance with legal requirements related to accessibility and non-discrimination. Measuring social impact outcomes provides a way to confirm whether intended benefits have been achieved. Metrics can include the number of local jobs created, improvements in access to services, or results from stakeholder satisfaction surveys. Collecting data through surveys, interviews, and engagement reports offers insight into how communities perceive the project's outcomes. This feedback can inform adjustments during execution and serve as evidence of meeting social objectives. Data-driven reviews ensure that the social goals outlined in the project plan are being met. They also provide a foundation for continuous improvement in future projects, ensuring that lessons learned are applied effectively. Addressing community concerns and feedback is essential for maintaining transparency and trust. Regularly scheduled forums, listening sessions, or town halls allow stakeholders to raise issues and ask questions directly to project leaders. Creating community advisory boards can formalize the feedback process and provide ongoing guidance for project adjustments. These boards can help bridge the gap between the project team and community members, ensuring that concerns are addressed constructively. Public responses should be documented and considered in decision-making. This ensures that stakeholder input is acknowledged and can be referenced in future project phases or reporting. Thank you for listening. Please follow baremetalcyber.com on social media and check out our books at cyberauthor.me.